Hello everybody, this week I will be doing DNA replication in eukaryotes for my video. Here is a quick diagram and it shows the replication process. On the right we have the original strand, which goes from the 3' end to the 5' end on the top, which is the lagging strand, and the 5' end to the 3' end on the bottom, which is the leading strand. So the first step is for helicase to split the strand up into two parts, the lagging and the leading strands. The reason they're different is because DNA polymerase III can only create new strands to match the original strand from 5' to 3' ends. It cannot create from 3' to 5' end. So the leading strand is very easily made by DNA polymerase III. But when you get to the lagging strand, there is an issue because it goes from the 3' to the 5'. So instead, we have an RNA primer created by primates that lays on top in different segments along the strand, which allows for DNA polymerase to go from the 3' to the 5' end the opposite direction. All that leaves is with primer, DNA polymerase III strands, primer, DNA polymerase III strands, and so on. So that leaves little gaps between them and segments of RNA, which you don't want. So what DNA polymerase I does is goes back through, it takes off the primers, it replaces with DNA strands, and it fills those gaps. And finally, the last step is DNA ligase, which is going to go back over the entire molecule and make sure that the strands are complete and you have full DNA strands. Okay, so as I explained earlier, DNA polymerase removes RNA primers, replaces with the correct pair, so adenine to thymine, cytosine to guanine, opposite thymine to adenine, guanine to cytosine. And finally, it connects the Okazaki fragments. So what happens if DNA polymerase I fails? So here you can see I drew a quick diagram. It's not the best, but it shows what I needed to show. So here we have the 5' end to the top to the 3' end, and the 3' end to the 5' end to the bottom. So what this shows is how that there are primers still there on the lagging strand, which are made of RNA, which you do not want. And there's gaps between the DNA strands and the RNA strand primers, which should be filled. So this can create serious health problems and is not good for you in the long run whatsoever. These are my sources, and that is all. Thank you.